In this video, I'll be covering question 4, part D from the 2023 AP Calculus AB free response no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see my other solutions, please check out my other videos. The first thing that I do on any AP Calc problem when I've got a graph is I want to make sure I double reinforce what this is the graph of. So we're looking at the graph of f prime up above here. We're looking at the graph of the derivative. Now that I know that, I go diving into D to see what D wants to find out. D wants us to find the absolute minimum of the original graph f on this closed interval from -2 to 8. Anytime you see that language, absolute, max, or min, this is a set of steps. It's the same set of steps every single time you see it. And so you just want to have these steps down as a part of your process going in to take this test. Step one of an absolute max min problem would be to find the derivative. Well, we've got that already taken care of for us. The derivative is the graph. We don't need to know the actual function here. Step two of the process is then going to be to find critical values. So we want to know where the first derivative equals 0 or where the first derivative is undefined. Since we are looking at the graph of the derivative equals 0 whenever we hit that x-axis right there. If we had any holes in that graph over there, we would have undefined derivative values. But we don't have any holes, so we don't have to worry about that. We're strictly going to be looking at when does the derivative equal 0. The derivative is going to equal 0 here at -1. It'll equal 0 again here at 2. And then it's going to equal 0 again here at 6. So we have three critical values. X equals -1, x equals 2, and then again at x equals 6. Then step three of our absolute max min process is we're going to plug in all of those critical values. I'm just going to call them CVs, and our endpoints, I'm just going to call them EPs, back into the original function, into the original f of x. And from there, whichever one is the largest y value, that would win your absolute max award. More importantly to us on this problem, whichever one has the smallest y value would be our absolute min, which is what they're looking for here. So we've got our critical values. We got that out in step 2. Our endpoints are going to be these two values here, -2 and 8. Those are the endpoints of our interval. So what we now need to do on this problem is we need to go find out 5 different y values. We need to know what is f of -1 equal. We need to know what is f of 2 equal. We need to know what does f of 6 equal. And then those are our critical values. And then with those critical values, we also need to know what is f of -2 equal, an endpoint, and what is f of 8 equal, our other endpoint. So here's, I think, the crux to this whole problem is how do we find out what those values are? We don't have an equation to work with. The only value that we have off of the original function was given to us up top here. They told us that f of 2 is equal to 1. So of all of those values right now, the only one that we actually know the answer to is f of 2 equals 1. We've got that one taken care of for us. Now we have to go find the other 5 so that we can compare them. Well, what we end up doing here, this is going to be going back to our definite integrals. Remember that when you take a definite integral, if I have some integral from a to b of my derivative function, that the outcome of that is going to equal f of b, the top value plugged into the original function, minus f of a, the bottom value plugged into the original function. And that what this side over here equals is this is the area between the curve and the x-axis, between whatever the a and b are. And so what you can do is use that graph from up above to find the area between the curve and the x-axis, and then we can use that to set it equal to two pieces over here. One of those values we'll know because we're always going to be using this for one of our bounds when we're setting these things up. So this is really just a bunch of definite integrals that we're going to have to solve to get back to those different specific values. I'm going to start at the furthest left one. You kind of want to work your way left to right through this. So we're going to start at -1 right here. Oops, nope, sorry, that's not the furthest left. The furthest left would be our left endpoint, f of -2. So I would start an integral from -2 as my lower bound, and then my upper bound is always going to be that x value there. So -2 to 2 of our derivative, which is that graph up above. And what I know is that that is going to equal f of 2 minus f of -2. So the key on this is that we're going to have to go find the area between the curve and the x-axis for this interval here. And this is where they just want us to use our standard geometry formulas to figure this out. You're basically going to always want to know 3 geometry formulas. You're going to want the area of a triangle, which is 1/2 base times height. You'll want to know the area of a rectangle, which is just base times height. And then you'll also want to know the area of a trapezoid formula, 1/2 base 1 plus base 2 times the height. So working our interval from -2 to 2, -2 is this endpoint over here, and then we're stopping at 2, which is right there. Looking at this, you quickly want to be able to recognize when you've got sort of pieces that will cancel out. Because remember, area above the x-axis is positive area. Area below the x-axis is negative area. So starting at -2, I've got this triangle here. Conveniently, though, that triangle is the exact opposite of the triangle down below. So those two triangles are going to cancel each other out. And what I really need to find to figure this out is this portion, this little triangle right here. So that's just going to be a 1/2 base times height. Starting here and ending here, that base would be 2. And the height is going to be going down to -2. And you can kind of see how they get out a negative area when it's under the x-axis. And that's going to equal, I know f of 2. That's why we're going to be using f of 2 in all of these setups. F of 2 is equal to 1. And that's minus f of -2, which is what I'm trying to find out. From here, we just have a little bit of algebra in front of us to finish this thing out. We want to get f of -2 by itself. First things first, I'm going to clean up the left side. 2 times 1/2 is just going to get us, those will cancel out. Multiplied by -2 is going to leave us with -2 equals 1 minus f of -2. And then from there, I would go ahead, we're just trying to isolate f of -2. So -1 minus 1, we get -3 equals negative f of -2, and then we don't want the negative version of that, we want the positive, so then we'll divide by -1, divide by -1, and we end up with f of -2 is going to equal 3. So we figured out what f of -2 is. That is equal to 3. It's obviously not the smallest value because it's not smaller than 1, so we could throw that one out, but we're going to keep rolling this same game through the rest of these. So now I'm going to go hit up f of -1 because that's the next smallest one. So again, we're going to go -1 to 2, f prime of x dx. That's going to equal f of 2 minus f of -1. And now we go do our area game again for this -1 to 2. So now we're starting here at -1 and ending at 2 again. So now I just have one giant triangle here. So as you look back through this now the triangle that we're looking at is going to be this triangle here. So again, we'll be using a 1/2 base times height. So this would be 1/2. The base is now going to go all the way across there. So the base is 3. The height again is going to be -2. And that's going to equal f of 2 minus f of -1. So cleaning up the left-hand side, the 2's will cancel. We'll be left with -3 equals f of 2. Again, we know that was given to us, so that's 1 minus f of -1. Move the 1 over, so we're going to subtract the 1, subtract the 1. We get -4 equals negative f of -1. And then last little move, divide by -1, divide by -1. We end up with f of -1 is going to equal -4 divided by -1 gets us 4. So now we've figured out that value. And we're just going to keep going on down the road here to figure out these other values. As we get to the next two, you're going to notice that the next two values, 6 and 8 are actually larger than 2, the one that we keep working with here. So you always want your lower bound to be the smaller number. So on these, what you're going to set up is this is now going to be integral starting at 2 and ending at the value that you care about. So this time we'll work with 6. And then f prime of x dx is going to equal, the top value is now 6, so oops, my brain just automatically puts a b, f of 6 minus f of 2. And now we come back and we have to figure out that area. So we're going to be starting over here at 2 this time and ending at 6. Well, we can get this portion of it from doing the area of a triangle. That's going to, again, be our 1/2 base times height. So we have a base of 2, and we have a height of 2 as well. The difficult part now is going to be from finding this little piece here that's the piece below that little part of our half circle. So to get that, what you need to do is you're going to need to end up taking the full area here of this rectangle. We'll take the full rectangle area, and when we're done, we're going to subtract off. They tell us in the language of the problem that we have a semicircle going on up top there. So this is where we kind of go next level on this, and we're going to need to find the area of that rectangle. So the area of our rectangle, I'm going to kind of do that off to the side over here. That full area there would be base times height. So base of 2, height of 2. And then we're going to subtract off a quarter circle, because the semicircle would be the full thing over here. We only need a quarter circle. So then this would be 1/4 pi, and then the radius on this, you can see the radius is right here. That would be a radius of 2, so times 2 squared. So for that piece, we're going to end up getting out 4 minus, this would be 1/4 pi times 2 squared is 4. So the area of that piece is going to be 4 minus, the 4's cancel out, 4 minus pi. Bringing that over here, so that's now giving us that little orange bit at the bottom. We took the full rectangle, subtracted off of that the area of that circle, and that's going to leave us with the orange bit. So we have the triangle from 2 to 4, that's what we started with, and then we're going to add to that 4 minus pi, and that all needs to equal f of 6 minus f of 2. Cleaning this up, we end up getting on the left-hand side here, again, these 2's are going to cancel. We'll get 2 plus 4 is going to get us 6 minus pi equals f of 6 minus f of 2. Oops, we know what f of 2 is. We might as well go plug that in now. F of 2 is, again, that 1 that we keep getting back out to. Then we'll add that over to the other side. So add 1, and we get 7 minus pi equals f of 6. So this piece is now 7 minus pi. And then we're just going to do it one last time. This time we're going to be going the integral from 2 again, because that's the smaller number, and we always need to be using that 2, to 8 this time, of f prime of x dx, and that's going to equal f of 8 minus f of 2. So starting at 2 and going to 8, we luckily have done most of that work already. 2 to 6, we got all of that. That was the answer that we just got out from up above. We know that that piece is going to be 2 to 6, we said was 4 minus pi. That was going to be our 6 minus pi right there. So that piece is going to be 6 minus pi. And then we get another little chunk here, again, recognizing when you've got equal sizes. That piece is going to match up with the orange piece from the other side. So we don't need to do this calculation again. We just need to know that that's going to also be another plus 4 minus pi going on right there. And that's all equal to f of 8 minus f of 2. We know what f of 2 is. F of 2 is 1. Keep cleaning this thing up. We get 6 plus 4 is going to get us 10. We have a pi minus a pi gets us minus 2 pi equals f of 8 minus 1. We will add that 1 over to the other side, and we end up with 11 minus 2 pi is equal to f of 8. So we figured out our last piece here of the puzzle. So 11 minus 2 pi. And now from that list, we just need to pick out the smallest value. You may not know what 7 minus pi is. Like, first and foremost, let's throw out the ones that are obviously not it. So 1 appears to be the smallest because 4 is definitely bigger than that. 3 is definitely bigger than that. When you look at this number, you should at least be saying to yourself, I don't know what pi is, but it's like 7 minus 3, which is about 4. So that's definitely going to be larger than 1. So that's not going to be it. And 11 minus 2 pi, that's going to be 11 minus 2 times 3, right? So that's 11 minus 6, so that's going to be somewhere around 5. We don't have to be super accurate. We just need to know if it's bigger than 1. It's definitely going to be bigger than 1, so that's not it. So in the end, we end up finding out that our absolute minimum value, remember the absolute min is the y value, so the absolute min equals 1. So for all that work, that was 3 points on the exam. They want to give you 1 point for finding all of your critical values. Then you're going to get 1 point for putting together all of those different points y values, finding all those y values as a point, and then you get 1 point for getting that answer right at the very end. So this problem, starts off pretty straightforward and then ends up in this place of finding a lot of area between the curve and the x-axis. Remembering that when you need to get back that original function and what you've got is your derivative, that's where the definite integral is going to come in to help you find those original function values. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.